Hello, and thank you for standing by, and welcome to the World Series on Data Virtualization. Our first session today is Data Virtualization, The Time Is Now, by Dr. Barry Devlin. My name is Kim Lukens, and I'll be the moderator for the World Series on Data Virtualization and travel with you on this journey. Please note that the webinar is being recorded and will be made available for on-demand viewing. Denodo Technologies is sponsoring the series of expert talks throughout the rest of 2011. I'd like to welcome Angel Viña, CEO and founder of Denodo Technologies, who will share some key points with you to kick off the World Series on Data Virtualization.
Thank you, Kim. It's a pleasure to be here today sharing with all this big online audience the initial conference of the Denodo World Series on Data Virtualization. The time has come for the full adoption of data virtualization in the modern enterprise. The number of incoming requests from all kinds of organizations, private and public, and the number of projects and deployments during the last few months have reached the level you need to see to finally declare data virtualization mainstream. And why is this happening now? Well, it's clear that the technology is ready and has reached maturity to respond to enterprise-class data integration and data provision requirements in both operational and informational projects, offering exceptional high performance and unparalleled flexible architectural solutions. We want to capture this very moment in this World Series of conferences on data virtualization. During this fall, and in 13 different sessions, we'll be bringing to you industry experts, analysts, system integrators, and first-class technologies to debate about ideas, best practices, use cases, technical solutions, and deployment experiences in their data virtualization research initiatives and projects. They will provide a quite good picture of where we are and how data virtualization is helping companies to become more efficient, more competitive, also more agile and responsive to business demands. The challenges in data integration today are well known. Managing the inevitable dispersion of data, the increasing diversity of database and data warehouse appliances, the last remaining edge of the unstructured data, the vast amount of information in the web and social networks ready to be tapped, the cloud breaking the walls of data centers, the need to efficiently process big data at reasonable cost, and the ideal of minimizing data replication. If you face these problems, you have good reasons to attend this series. In our experience at Denodo, we have seen organizations saving costs, accelerating product development, making IT lighter and more elastic, responding to these challenges by using data virtualization. You should be the next, and we want to be your partner in this process. Data virtualization is also a phenomenon all around the world. It's happening in the 5 continents and across all verticals. We want to contribute to this wave by inviting in this World Series companies in different sectors like telecommunications, financial services, life sciences, retail, manufacturing, internationally recognized speakers from several countries. We have prepared a comprehensive program covering architectural topics, technical sessions, discussions on business benefits and use cases, and leading-edge trends. The speaker today is a widely respected consultant and lecturer in business intelligence and data warehousing, Dr. Barry Devlin, who will be joining from Cape Town, South Africa, opening the series from the continent of the future with a session titled Data Virtualization, The Time Is Now. Please have fun, enjoy the content, and eventually get any of those tickets for the Baseball World Series or any other international sport event through our marketing offering. And overall, help us to build the knowledge base on data virtualization around the world and be part of this community. Thanks for being with us, joining this event. Kim, back to you.
Thank you, Angel. Yes, as Angel had mentioned, we are very pleased to offer this series of webinars. And on that note, I'd like to turn the presentation over to Dr. Barry Devlin, Principal of Ninesight Consulting and an expert on data integration, warehousing, and business intelligence. Would like to remind you that you can submit any questions to dvworldseries@denodo.com or in the question box in the GoToMeeting.
So good evening, good morning, good whatever it is, time in the day for you. It is a real pleasure to be joining you from Cape Town. Thank you for that introduction. Yeah, data virtualization, the time is now. I was playing a little bit with the title. The time is now, as Anka said, it is at the time now in terms of the marketplace. But also it is the time is now in terms of data virtualization itself. And by that I mean that, that one of the key things about virtualization is that we can get our data now. And that's going to be part of the examples that I'll show you later on in this presentation. So this is the start of this World Series. It's really going to be an exciting time. I've been around in this area for so long. Back in the mid-'80s, I was one of the founders of the data warehousing industry, and times were different then, and we'll talk about that again a little bit later. But it is an exciting time now. It is a time of change, a time of new technologies, a time of new business needs. So let's get right into the presentation itself without further ado. You can read my biography on my website, or you can read it here later on the slides when we replay. So on the next slide, the question that the title that I pose is Data Virtualization, the time is now. So let's ask some questions about that. Why virtualization? Why now? So on this slide, which is, I'm sure, any moment going to come up on the screen, why virtualization? There we go. It may be a delay between the US and South Africa, but we'll work with it. Why virtualization? It's the need for timely access to a single, consistent understanding of information and activities from across all sources. And that's for everybody in the business. It's for the executives, the analysts, the managers, the frontline staff. It's also for partners, regulators, and customers. So we're really thinking about virtualization as virtualizing the information, all of the information, to all of the people that need it. And you may think in the past we did things like, let's distribute it, let's duplicate it, let's copy it. Virtualization is saying things like, hang on a minute, let's not do that. Let's try and get to a single, timely, consistent view of the information. So that's why virtualization. But why now? Well, now change is happening so fast. It's happening so fast that any delay in decision making or any inconsistency in information can quickly become a lost opportunity or even a major crisis. So that's why we do virtualization. That's why it's important. But I haven't yet answered you the question of what is data virtualization. So let's go to the next slide to see that. Data virtualization. Where do we get a definition? Well, these days we get a definition always from Wikipedia. And in this case, Wikipedia's definition is not too bad. I've copied it out. I've put it on the box on the slide here. And you may see there's a couple of colors here, different colors. And that's where I've been playing with it a little bit. I've added and changed a couple of things. But let's read it as I've written it. Data virtualization is the process of abstracting, accessing, transforming, combining, and delivering data contained within a variety of information sources so that they may be accessed by consuming applications or users when requested, without regard to their physical storage or heterogeneous structure. So as you can see in this, I've added one word and I've changed another. I've added the word accessing because I think that's important. You could say, well, delivering might be somewhat part of it, but I just want to make some points about accessing as we go through this presentation. And the word I've changed was federating, which I've replaced with combining. And I will tell you why that I've made that change in the next slide. It's important, and it's going to be it's important that we get the words right here, because as we talk about this, there's a lot of different uses of words. In some senses, we've got synonyms like information as a service. On other cases, we're using data integration. But I want to go back to two old words, which I call kissing cousins of data virtualization. Maybe I should have called them ancestors, and in some sense they are ancestors. But they're actually still in use, these words, so they haven't quite died out like ancestors would have. The first of these is federation. Federation strictly means the federated query across distributed relational databases. So in terms of our definition, it actually deals with accessing, combining, and delivering data, but in a homogeneous environment. And it's been available since the late 1980s in relational databases from large vendors like IBM, Oracle, and so on. So that's federation, and although sometimes the word is used still as a synonym for data virtualization, I'd like to keep it separate. The other old word is, or old phrase in fact, is enterprise information integration. And what that did as a term was it extended the reach of federation to heterogeneous sources. So it integrated data from heterogeneous sources, and that basically emerged, well, it first emerged in the early 90s. Edda SQL, for example, delivered some form of EII back then, but it really became popular in the late 1990s and in the early 2000s. And in fact, when I was working for IBM at that stage, it was one of the products that I was involved in, Information Integrator. So it added one more piece of the five of data virtualization, which was the transform. So it had a technical transformation aspect in addition to accessing, transforming, accessing, combining, and delivering data. So yeah, they're the kissing cousins of data virtualization. But let's go back to data virtualization itself and talk about the 5 key aspects of data virtualization on the next slide. First of all, thanks to Denodo for the graphic on the right-hand side of this slide. The U-shaped arrow, I think, gives us a pathway through this architecture of virtualization that Denodo used. At the top, we have all of the various consumers, the data consumers in the world. At the bottom, we've the data sources or providers. And in the middle, we've got this virtualization platform. And this looping arrow that I've drawn on shows us the pathway that we go from the consumers through the layer, the platform, the virtualization platform, to the sources, back through the platform, and back to the consumers. And that's the path we track with these 5 key aspects. So the first of these is abstraction. Abstraction from a technical to a business view of the information. This is probably the key difference between federation, enterprise information integration, and data virtualization. The addition of abstraction as a concept and as a reality within this technology. It's really important when we think about this, because what we're doing when we do data virtualization is we give users, business users who are not technical, we give them access to data and information across many sources, in many locations, in many different formats. And you know what? They don't want to know that. All they want to do is to get the data that they need, or the information that they need, for their business process, for their business job. So turning their view, that business aspect, into something that has technical validity, that goes to the right places, that does the right transformations, that delivers the right results, is key. So abstraction is what really makes this data virtualization usable and useful to business users. So that's the beginning of our U-shaped arrow. The end of the U-shaped arrow, we'll just go across to the very end, is the delivery stage, providing the results to the users or the applications as needed, exposed as data services. So without needing to know what's inside them, giving them a particular format or particular shape, but delivering them in a way that's particularly usable, that's delivery. So let's move down a layer. We've come to transformation and combination. These are, in a way, the 2 key factors, the 2 key pieces of the virtualization layer or platform itself. the transformation. On the way down, it's a transformation of that abstracted view, that technically abstracted view of the requirement to a common schema. It enables us to address quality. It enables us to go in there and figure out what it is, where do we need to go, where do we need to get it from. And on the way back, the combination to join and combine data returned from various sources without the need to understand where they came from or what they look like. And finally, the last point, the access, the interfaces to all of the required data sources, even the unstructured data sources, even the web. As you can see across the bottom of this graphic, databases, data warehouses, enterprise applications, the cloud, XML, Excel files, flat files, the public web, collaboration, Web 2.0 environments, PDF documents, mail, you name it. The idea is to enable the data to come from anywhere, then back up through the platform to the users in the way they need. So you think this sounds like great stuff. This is a wonderful way of getting at all of the data we need. But as we see on the next slide, there has been some historical resistance in the data warehouse and BI community to federation, to enterprise information integration, and indeed now to data virtualization. And I'd just like to start to deal with that because I think it's very important that we understand why that resistance is there. Is it still valid? And I'm going to show that to you that I think it is generally not. But why it's still there and why it's there and what we need to do to understand it and to move beyond it. So the picture on the right-hand side of this slide is, well, that's an old data warehouse architecture, and it's one that I drew back first in the, I guess it was the early 90s, and widely used as the architecture for data warehousing. Let me just run through it very quickly. At the bottom, you'll see the operational systems, the sources of data. Through ETL, though, that data is moved into an enterprise data warehouse layer, which is a way of physically consolidating data to predefined common schemas in order to cleanse it. In other words, we knew at that time back in the 80s the operational systems were not very clean. They were dirty. There was consistency issues between them. There were reconciliation issues between them. There was perhaps historical information missing from them. They had codes and various ways of describing information that weren't particularly understandable to end users. So all of that stuff was being handled by the ETL, extract, transform, and load processes into the enterprise data warehouse. And then because the enterprise data warehouse might have performance issues or indeed was too big for an end user to handle, we would then move it out to a data mart platform, again via ETL, to make it available to the end users. And metadata down the left-hand side describing all of the technology, the technical changes, and in many cases the business meanings and information around the data. But you'll note one thing about it. It was about creating the data in advance for use by end users and business analysts, managers, and so on and so forth. Because, as I said, the data in the operational systems was dirty or inconsistent, mismatched in timing, lacking in history, and difficult to understand. And so you might ask the question, are these reasons still valid? Is this still so today, 25 years later? Are the operational systems of the business, are the many different sources of the business so unreasonable that we should still use the old architecture? And maybe there are some cases where we do need to do that. But in general, things are changing. The modern business intelligence, the modern needs of business intelligence, the modern business needs of how do I get at and how do I understand my business, and indeed modern technology give us both the drivers and the opportunity to do something different. Let's talk about the business drivers first. One of the things that my clients have been telling me again and again over the last few years is that they need to integrate business intelligence into their business operations. Business intelligence needs to be part of the day-to-day process of what they do. whether they're in banking, whether they're in telecoms, whether they're in the health industry, it doesn't matter. It also doesn't matter whether these people are managers or whether they're frontline staff. They want to have business intelligence integrated into the business operations. I call this a closed-loop business, or sense and respond business is another phrase we use, but that is a very important driver for business today and a very important driver for business intelligence. And it leads directly to number 2, especially when we talk about frontline staff. That is their need for real-time or near real-time information. And in the past, that has proven to be a problem, getting near real-time information into a data warehouse, because as I just described it to you, there are many different layers, there are many different pieces of ETL that have to take place before we get the data from the operational environment or from wherever it's coming into the data mart at the top. So the drive for real-time or near real-time information is a very strong drive that is in the BI world today. Number 3 in the business side is the expanding use and need for collaborative social information, whether that's stuff that has been stored in emails, and it's just the very old-fashioned stuff, whether it's instant messaging, whether it's what's going on in the Twitterverse. All of that information is becoming much more interesting and much more useful to business, particularly in the area of marketing and in terms of supporting call centers and supporting error tracking and so on and so forth. So collaborative social information is driving a change in BI. And what is that change? That change is that the sources, as we see down in the technology side, are less traditional. They're less structured. They're less like the things that we've used, the transactional stuff that we've used in the past. So in the technology side, we're getting this growth of, and I'm out of sequence here, of course, but I'm getting this growth of non-traditional sources, which are less structured, which are coming from the external world, and typically extraordinarily voluminous. But as I said, and I posed the question in the previous slide, is it okay to think that our operational sources are still dirty? Well, I'd like to suggest to you that over the last 25 years, they've improved. We've spent a lot of money in putting in SAP, for example, and some of the benefits of putting in off-the-shelf systems like SAP and Oracle and so on and so forth, business systems, is that we get a more integrated view. We get, hopefully, better, cleaner, more integrated data. And finally, what's been improving in the technology has been metadata. One of the things that I've discovered, again with my clients, is that as they've gone to do SOA, service-oriented architecture projects, service-oriented architecture by its very nature demands, in fact, it cannot work without real-time metadata. And that drive for metadata in SOA has led to an enormous improvement in the metadata environment and the ability to do things that we couldn't do before. And then, of course, there's the other technology which we don't have time to talk about today, but we've got faster processors, we've got solid-state disk, we've got even in-memory databases being talked about. All of this technology enables us to do things different. In fact, it mandates that we do things differently. And on the next slide, you'll see that I've been thinking about this and the implications of this for a number of years now. And the way I've been thinking about it is that, well, you know, I'm an architect, an IT architect by profession, and I like to draw things into a picture that people can understand. I like to get a view of, an overview of the way the world might work and how it might be different. So I've been playing with this new layered architecture, which I call Business Integrated Insight, or BI to the power of 2. And the reason that I've been using this architecture is that I want to explicitly include all types of information, business intelligence type of information, operational information, social information, And I want to include both the business and IT aspects of all of this. So I've come up with this layered architecture, but a set of layers that are very different from the architecture that you saw in slide 7, where the layers were all data layers. In this architecture, the layers are information at the bottom, process in the middle, and people at the top. And I'm just going to spend a couple of minutes talking about those briefly. The bottom layer, information, is the business information resource, is what I call it. And as you see written there, it's all the information of the business. And yes, I do mean that, all the information of the business. No matter where it comes from, no matter where it's stored, no matter what its type, I want to emphasize that we're talking about an enterprise-wide view of all the information in the business. And that's quite scary for some people because we know as architects and as implementers how diverse that information is, how many places it's stored, how many ways that we have created different stores for different purposes, for different performances, and so on and so forth. And in the past, we data warehouse folks have said, take it from wherever it is and put it in the warehouse. If we're really honest with ourselves going forward, given big data, given the way that the world is changing, does it make sense to say, let's make copies of that information? I think the answer is no. The answer is that we have to use it where it lies, play it where it lies. So that's our business information resource, all the information of the business. The process layer, I call it the business function assembly, is all of the processes of the business. Yep, I said all of the processes. And I mean that by that business and IT. In the past, we've sort of separated the business processes out and said, we IT are going to make you your business processes, and we have our own processes for making your business processes. But you know what? We've got mashups these days. We've got people building their own applications. We've got users playing with data, playing with process. So we have to begin to deal with process as a single entity, as a single view, which creates, manages, accesses, and uses all of the information within the business. So the business function assembly is all the processes of the business. And the top layer of people, the personal action domain, addresses all users' intent and action. So there's a lot of the word all on this slide because it's really important, I think, to have a holistic view of what's going on. And I'm not going to spend much longer on this. I'll point you to the slide, to the paper that's mentioned at the bottom of the slide, and the link that's shown here. Go read it. It's 2 years old, this paper now, but there's more there and on my website on 9site.com, where you can find a lot more information about this architecture. I just want to say to you, it's not just me. This architecture is actually something that lots of people are talking about, perhaps with different names and different views. Everybody is beginning to say we cannot continue to have the siloed view of IT that we have. So it's really beginning to think operational, informational, collaborative, let's bring them all together. Now, a key component in this architecture, whatever you may call it, and I just happen to call it BI to the power of 2, a key component is data virtualization. Why is that? Well, I think you can already guess. If I've got information that is distributed all over the IT environment, perhaps all over the world, data stored where and wherever is best suited, on personal devices, on servers, in the cloud, in the relational schema, to whatever it happens to be, well, you know what? We need to be able to have we need a tool. We need a tool which can access data in many different places. And hey, that's the definition of data virtualization. That access is part of one of the key 5 components of data virtualization. Just a comment in passing here, metadata is just one more type of data. We've, in the past, always put it over on one side and said, there's a box and let's manage it separately. I think if you really start to explore metadata, you'll see that some of it, and indeed eventually all of it, is of use to business users as well. So why don't we just accept that it is part of the business information layer? So across this layered architecture, I've already put in bold the 5 key aspects of data virtualization. From the top, abstraction, delivery, transformation and combination, and down to access. These are the same layers we saw way back in the Denodo architecture picture on slide 6. These are the same pieces of the jigsaw puzzle joined together by the same pieces of processing power. I've added some additional words here: discovery, integration, metadata, distributed caching, all parts of the jigsaw puzzle of data virtualization, the components, the features and functions that we need to get from this distributed information, disparate data, to a unified view of it through a unified set of processes on usage and management of business information across common business and IT processes, from real-time to long-running processes, all the way up to the business view of business activities and information with true business-related meaning, with IT empowered to do what it needs to do and efficiently able to do it. This is, in a way, when we talk about mashups, what we really need to talk about. This is how we move forward with the idea of a BI2 architecture, but indeed with data virtualization as the underlying key for it. So let's step back to the propositions, the 5 value propositions that data virtualization brings to us. So number 1, and I think we've hit on this again, but I cannot emphasize it often enough: providing an integrated business view. These days, it is not acceptable, I believe, to talk about disparate business views. That doesn't mean everybody has to see the same thing or have a single version of the truth, but it does mean that it has to work together. It has to be integrated. That integration means masking technical complexity, diversity, and location. So the first value proposition of data virtualization is to mask that technical complexity, to mask the technical change as we move data around, as we store it in different places, in different formats, whatever we need to do to make it perform, to make it work. And to compensate for business differences, to enable the salespeople to see their view of the data, which may be different, as we well know, from the financial people's view of the data, but they need to be integrated in some way. They need to have an underlying reality. And that's a key value proposition for data virtualization. The second value proposition is the one that I mentioned in the title of this presentation. The time is now. The access to real-time data in transactional or operational systems. The need to know what is happening now. Not for everybody, not for everything, but when I need it, I do need to know that it is accurate, it is up to the moment, it is the exact right answer. And I'll be showing you some examples in a few moments to give you so that you can see where that is needed. And often that need to know what is happening now needs to be combined with the historical view of how does this fit in the context of what's happened in the past? How does this fit in the context of our overall view of where we want to go in the future? This moment is but a moment in a continuum of past, present, and future. So the access to real-time data in transactional systems is a key piece of a key value that data virtualization offers. Number 3, information from external or non-traditional sources. So we've mentioned this already, but again, we need to emphasize the value coming in here. I know that there are consultants, there are gurus out there in the world who say the answer to unstructured, and I hate that phrase unstructured, but let's call it unstructured data, is to bring it into the data warehouse. I do not believe that this is the right answer. In my view, there is far too much of this stuff out there to copy it into the data warehouse. It has the wrong structure. I mean, data warehouses are built on relational databases, and yes, I know that relational databases can handle unstructured blob data, but that's not their design point. The design point of content stores, for example, is what's appropriate for unstructured, or as I call it, soft information. So information that's coming from those external sources, from the web, from content stores, I need to be able to get at that. I need to be able to join it with our traditional hard data from the warehouse. So the value proposition number 3 is the ability to get at the information from external or non-traditional sources. Value proposition number 4 is agility. These days, our users, well, they're very impatient. They not only are not prepared to wait for the development and deployment of systems, but they're not prepared to wait for the delivery of data once the systems are built. And data virtualization, as we'll see in a moment, is very useful in providing access to information-intensive and rapidly evolving environments. We can use it to introduce new information sources quickly. We can use it to allow access to data as it changes in order to meet rapidly evolving needs. So agility is a key value proposition of data virtualization. And related to that is the ability, number 5, the ability of data virtualization to deal with or to address the issues of duration or the cost of enterprise-level consolidation projects such as enterprise data warehouses or master data management and so on and so forth. It provides us with the opportunity to improve the responsiveness of IT, to provide more value from IT, gives us the ability to do prototyping and to say, this is what you can get. We may have to do some additional work to make sure in the long run that it's clean or that it has the proper quality aspects, but we can bring it to you quickly and we can bring it to you with sufficient quality to play with it initially. So these 5 value propositions I'm going to show you in 3 examples, 3 quick examples of how virtualization can play in this environment. So first, let's look at the time is now. Virtualization solves the real-time conundrum in business intelligence. So, for example, let's think about call centers and their customer support agents within a call center. They have a need whenever they're talking to a customer to have access to historical information, which typically is coming from a data warehouse, and current real-time facts. The customer at the end of the phone is saying, you know what, I just did a transaction 20 minutes ago or 15 minutes ago. Why isn't that working? How is it not showing on my web screen? What's going on here? I feel like I'm being ignored. So the call center customer agent really needs to be able to see the historical view and the current real-time view. The traditional approach to this, which is on the left-hand side of the picture, is to use something called an operational data store, or ODS. And I joke every time I see this phrase. If you say ODS quickly, it sounds odious. And to me, the operational data store is not something that I recommend to people. I've never recommended it, although it's been around for many years. And the reason is that I have some issues around it. One of them is that if I want to have a complete set or a complete access for my customer support agents to all of the current real-time information, that means I have to be loading information into the ODS as fast as I can with considerable volumes of information, much of which will never, ever be used. Now, I grant you, on the positive side of this is I do have a predefined schema which will enable me to do some cleansing and to do some consolidation within this ODS. But one of the issues I have is the volumes that have to be loaded in there, the time limits that have to be loaded in there, and the fact that, as I said, often it doesn't get used. So on the right-hand side of the picture, you'll see that I have an easier way, a better way of doing this once I adopt data virtualization. Because what I do is I take only the data needed from the operational systems. I can take it real time. I'm going in there and saying, give it to me now, the exact current value. I can do it agilely. I can do it fast. I can go there quickly. It's real time. I can combine it with data from my data mart, and I can give it to the agent in the call center when needed. There may be some work that needs to be done around consistency, of course, because as we know, there can be issues that we have solved in the ETL world. But I believe that over the years, much of the work that has gone into cleaning up our operational systems and making them more real-time and more accessible on the web actually has addressed many of those consistency issues. So in this particular instance, virtualization, I do believe, solves the real-time conundrum in business intelligence. The second example I just want to deal with is the use of data, the use of data delayed BI delivery. So what if I want to get data from virtual data marts from multiple sources? How do I satisfy urgent user needs for information? So the traditional way of doing this has typically been to build a new combined data mart. So a user comes up with a user, or a department comes up with a new set of needs. It has been solved in a way before because the data has been extracted into the warehouse or into various data marts, but those data marts the data needs to be combined. So the traditional approach has been to build a new data mart, and this works for sure. Although there are issues around the development time because we have to design this new data mart, we have to figure out the various different sources, so there probably is a development phase. If we're building multiple new marts, build marts upon marts and marts upon marts, duplicates upon duplicates, our sizes and volumes are going to grow enormously. And one of the issues that many of my clients have these days is they have so many data warehouses and so many data marts that they do not know how to count them anymore. That's a problem. It's a problem of management. It's a problem of consistency. It's a problem of quality. And I, for the last couple of years, have been advising people, reduce the number of data marts. How can you combine data marts? How can you collapse data marts back into the warehouse? And some of that's possible. But here again, data virtualization brings us an answer to this problem. It allows us to go directly to these individual data marts, or indeed to the data warehouse itself, to get the data we need to satisfy particular needs. So it's getting the data that we need, and it's getting it quickly, both in terms of development time and in terms of access time. Again, we have to question, we have to make sure, I suppose is the right answer, we have to make sure that the consistency issues are dealt with. And we do that through the metadata, we do that through our design of the data virtualization code. The third example I want to talk about briefly is the combination of hard and soft data. Virtualization gives us a single view of content and data, which is one way of calling it, or hard and soft data, as I sometimes call it. And a good example of this is a campaign management application. Campaign management applications typically need to combine historical information coming from a data warehouse with real-time facts about what's going on as responses, and shown it on the slide, but it should satisfy the needs exactly. But on the other hand, we do have to recognize that it's yet another copy of the data. It's coming from various different sources. It's yet another set of duplicate data that we have to manage and understand. These advantages here. So we can reuse the existing data and content. We don't have to recopy it. We don't have to take it from a different place. As we've mentioned a number of times before, we're getting real-time data access. We get the agility that we've needed in order to get at the data both in terms of development and in terms of deployment quickly. Do we manage to bring in the specific campaign management needs? Well, that's what we need to bring into the actual front end at the CM application itself. So we build that on top probably in the end user environment itself. And data virtualization is essentially the set of pipes that we have in the background to get the data into that application. And the application becomes much more simple because it's getting all of the data from a single environment, the data virtualization environment. So that's 3 examples of data virtualization in use. And I've mentioned a couple of questions that we always have to encounter and we have to deal with when we talk about data virtualization. And I just want to deal with them briefly here. Some of them still have, answers that are somewhat under construction, of course. Data virtualization as a technology has evolved over the years. It is still evolving. But the key questions are different sources. So we need to look at our dealing to see if it goes as far as non-relational sources to legacy sources. Some of them are very legacy, to content. And how about the emerging sources? Big data, NoSQL, the cloud sources, the web. So one of the first questions we need to look at in terms of data virtualization is how we got access to all of the sources that we need to. And I think today the technology mostly addresses that. The second question is, can the data be integrated on the fly? And there are 2 parts of this question that we need to be careful about. One is meaning, and the second is timing. Meaning is about how to make the definitions consistent. Are we sure that we've got this data from the same time? That's some piece of work that we need to do in our design. In number 3, question number 3 is, can the performance meet our business requirements? So we have to look at issues of network bandwidth. When we send that query across the network, is the response going to come back in time? Will there be impact on the source systems in terms of their response time? And that's one of the fears that operational systems developers and owners always bring up. If I send in one of these real-time data virtualized queries into this source system, will it interrupt the vital functions of that system by running a big query? So we have to be careful what we're sending in there, that it doesn't do that. Is the response time going to be predictable? Because we've got this big network in between. If we've not got predictable response time, will that be acceptable? And finally, how to balance agile data delivery with secure access. My clients, some of whom are in the financial industry, will always ask that question. If I'm going to let data virtualized queries come in there, can I be sure of the security? Can I make sure that privacy issues are covered? And again, it's a design point. So there's a number of these questions are answered by how do I design my application? But on the next slide, the other aspect of the other answers to these questions is, in fact, the technology that has advanced over the years. How do best-of-breed data virtualization platforms differ from the prior approaches? Well, 2 key things that we should look at here is performance improvements and the meaning, timing, access, and so on of these tools. Performance improvements is done through caching. I'm not going to go into the details here because we've got 13 more events in this series, and I'm sure that other speakers will deal with this in more depth. We've got caching from basic snapshots through to advanced change data capture. We've got managed replication. That means that our virtualization becomes part of our data warehousing toolset. We've got query optimization based on a better understanding of the data and its distribution, and that's a metadata thing. We've got cost and rule-based optimization going on. We've got the ability to delegate queries, to distribute queries. There's a lot of developments that have been done in the data virtualization tools that really do address some of our earlier performance concerns. And then the metadata is the answer to the meaning, timing, and access issues. metadata, which is much improved over what it was 20 years ago or even 10 years ago, particularly as we look to using service-oriented architecture projects within our businesses. I'm going to move quickly along. I see that we're coming towards the end of our hour, so I'd just like to go to the next slide and ask the question, first of all, does data virtualization mean that we don't need the enterprise data warehouse anymore? So are you asking me to kill my baby? Well, the answer, of course, is no. I certainly do not want to kill my baby. But there is some change coming, and I think the changes could be summarized like this. If you think about the enterprise data warehouse of the past, our approach was typically to push everything into it. I think it's going to shrink. It's going to get smaller in relative terms. And on either side of it and around it, there will be analytical data stores and content stores where we will be holding information in the format and in the technology that best suits those needs. We will have data that continues to be in the transaction or operational systems. So we have this data which will be in many places. Data virtualization will be a layer on top of all of this that provides access to information in all of these sources. And the metadata layer that I show in between is the magic that holds it all together. That's the glue that holds it together and makes sure that we understand what the sources are, where they are, and indeed the abstraction of those sources that is necessary to make it understandable to the end user. In conclusion, therefore, I'd just like to make 4 points. The first is that we have seen in business terms that there are 2 key drivers going on for change in the business intelligence environment and indeed in the IT environment in general. And that is the explosion of data sources with a wide variety of formats, the explosion in volumes and variety. We cannot really expect to put all of that into a single data warehouse environment. And the demand for timeliness, both in development and execution. These are key drivers that really make me quite convinced that data virtualization is a very key technology for the future. Traditional ETL-based approaches is no longer sufficient. We're just having too many copies of high-volume soft data. We're just having too many efforts to get real-time information running through these ETL systems. We need to stop copying information and start getting at the information directly where we need it. And that leads us to, well, there's a lot of stuff that's already been done. We've got an increasing number and variety of successful projects that exist both in the BI world and beyond. That leads me to believe that data virtualization is a key component of emerging architectures for business intelligence and for IT more broadly. I have one more slide, which is a list of some further resources that you can go look at and deal with, or look at in your own time, have a read in this whole area. And in fact, one of them, which is a keynote from Strata earlier this year, you can actually watch. It's just a YouTube video. With that, I'll leave you. Thank you very much for joining me on this first webinar of the of Denodo's Data Virtualization World Series. And I wish you joy and pleasure as you follow that journey on that series over the next 13 sessions. Thank you very much.
Thank you, Barry. And to the audience, I encourage you to send any questions to dvworldseries@denodo.com. All of the questions will be reviewed and provided personalized responses. We will also be providing a link to recordings via email for on-demand viewing. We encourage you to attend the entire series on data virtualization. Our next session, October 11th, is high-value uses for data virtualization, analytical, operational, and data management applications. October 19th, we have Agile Telecommunications Information Strategies. We have reached the end of the webinar for today. I'd like to thank our speakers again and thank all of you for your participation. Signing off until next week, your host, Kim Lukens.
The World Series on Data Virtualization is brought to you by Denodo Technologies, the leader in data virtualization, delivering unmatched flexibility, performance, and ROI.